Today we're learning about graphing attributes of absolute value equations. So today's lesson is mostly just taking notes. We're not going to do any examples. We have one little example that you can see below, but a lot of vocabulary and just kind of doing stuff we've done before, but now describing it over an absolute value equation. So first of all, we have x-intercept, the point or points where the graph crosses the x-axis. That should be pretty familiar to you. And sorry, it's not going to fit great. The value of y, remember, must be 0. Whenever we're finding our x-intercepts, y is equal to 0. This is also called, and here's where we have those other vocab words, roots, zeros, and solutions. Roots, zeros, and solutions of the equation. So x-intercept, the point or points where the graph crosses the x-axis. The value of y must be equal to 0. This is called the roots, zeros, or solutions of the equation. To find the x-intercept, you can graph and see where it crosses the x-axis, or you can set the equation equal to 0 and you solve. Now y-intercept, when we're dealing with functions, remember, it's only going to cross the y-axis one time. So this is the point where the graph crosses the y-axis. That's our first blank, y-axis. And the value of x is 0 for this one. So it's kind of opposites. Just remember, x-intercept, the y equals 0, y-intercept, the x equals 0. So to find it, you can graph it, or you can plug in 0 for x in the equation and solve. So you could find f of 0, and that would find your answer. Symmetry, we've talked about symmetry before. A function has symmetry if a reflection or rotation. So reflection, I'm not going to use yellow, this doesn't look very good, not dark enough. We'll try red. Reflection or rotation. Carries the graph onto itself. Or we think of the vertical line that divides the graph of an absolute value function into two parts that are mirror images. That is called the axis of symmetry. And you'll see us list AOS a lot. Axis of symmetry. And the vertex lies on the axis of symmetry. So this is the first time we've used this word vertex. A vertex lies on the axis of symmetry. Or vice versa, you could say the line of symmetry is the x value of the vertex. The maximum, that's the greatest value, greatest y value. So you should feel pretty comfortable with most of these. Symmetry, a little different. Maximum is found by graphing. You find the highest y value. You might need to use substitution to find it, to be exact. And minimum is the least y value for the interval of x values. And same way, you can graph it, or you might need to use substitution to find it. So we're going to label this graph on the right down here with all of these different things. So let's start with our x-intercepts, and we'll put x-intercepts in blue. So I'm going to circle them. X-intercept, where it crosses the x-axis. So I'm just going to label them over here in blue, x-intercept, and it's at -2, 0, and 4, 0. Okay. Then we'll go with our y-intercept. We'll put that in green. The y-intercept, right where I circled there. That's our y-intercept. and that is when x is 0, so you have 0, 2. So you can see in both our values, the x-intercept, the y value is 0, the y-intercept, the x value is 0. So symmetry. So we want to find our axis of symmetry. I'm going to put this in yellow. So the axis of symmetry goes right down this dotted line. That's our axis of symmetry. If we folded it along that, it would fold right onto itself. So I'm just going to label it AOS, axis of symmetry, and it's at x equals 1. Like I said, you can always find it by looking at your vertex as well. And we'll talk more about vertexes later, or vertices, sorry, I'll say it the right way. But it's on x equals 1. Now we want to look at our maximum, and the maximum is right on that axis of symmetry. So we would say our max is at 1, 3. And if you look, our minimum, there's no minimum because they go down to negative infinity, so we'd say min would be none. So if the graph opened upward, up, we would have a minimum. Opening down means we have a maximum. And I think that covers, that covers all the different things, the attributes of our graph. So a few more just things we need to know. We'll start talking about parent functions, and the parent absolute value function, a parent absolute value function has the form f of x equals absolute value of x. So the parent function means there's no stretching, compressing, no shifts, no nothing. It's just the absolute value of x. And this is a function is of the form, and it's going to be f of x. I'm going to zoom in as much as I can. F of x equals, in absolute values, mx plus b, and then a plus c on the outside, where m is the slope of the function, b is the horizontal shift, that's left and right, so I'll just say left, right shift, and c is the vertical shift, the up and down shift. So inside the absolute values is the horizontal shift, outside is the vertical shift. When b is negative, so here's where you need to remember, inside the absolute values, you have to think opposite. When b is negative, shift right. That's opposite. When it's positive, shift left. So it goes kind of against what you would think. Now on the outside, when c is negative, shift down. So outside it stays the same. Outside is the same. Inside is opposite. So when c is positive, shift up. Okay, so, and we will go over this more in future lessons on which way the shifts go, and pretty soon you'll just know it. But just remember, inside the absolute value, you look opposite of what it says. So the b value, negative means go to the right, positive goes to the left. C value, negative, stays the same. You go down and up based on the form. So a few just kind of quick hitters that can help you out. When you have a negative out front, it flips the graph. So that means the graph we're looking at up here that we already labeled, that one would be a negative something with absolute values because it flipped. It's pointing down. B term, B is opposite and C stays the same. So hopefully that helps you. There's the whole page. Looking at it one more time, just kind of going over terms, definitions, and what different values mean. And hopefully that's just kind of a quick help for you understanding graphing attributes of absolute value equations.